We are going to start, of course, in continuation only, because we have discussed about the oscillations, as I've said in the previous class, and waves. You will be able to understand if you are having the complete knowledge of the chapter of oscillation. So I can say this we are doing in continuation only, but of course this is the first lecture on waves for you with you. And the name waves you are very much familiar with, because you have even played, even you have learned in the lower classes, that if you are having a pool of water, you are throwing a stone in it, and when the stone reaches the water, then you are able to see the waves on the surface of the water. So these are water waves, we call it. So what is a wave? Or if I say wave motion, the meaning is same, and I can define it as a kind of disturbance which is traveling through a medium due to repeated vibrations of the particles. So what is happening? Particles are vibrating about their mean position. I can say this particle, it vibrates up and down, and it allows to make the another particle vibrate in up and down, and as a result, by joining the position of the particles, we get this type of structure with us, which we are calling it as the wave or the wave motion. So if I say wave or I say wave motion, the meaning is same. So if I'm talking about wave or wave motion, it is simply a kind of disturbance in which the particles are vibrating about their mean positions, and as a result, disturbance is handed over from one particle to the another without the actual movement of particles. You can note this thing, that particles are not leaving their position. Particles are not leaving their positions. They are simply vibrating about their mean positions. And as a result, energy is being transferred and the particle position is not getting changed. So without actual movement of the particle, I can say and only energy is getting transferred. So it means particles are not leaving their positions and only the energy is getting transferred. So particles are not leaving their positions. Like if you stand in a row, so many students are standing in a row like this, and like in the sound waves, if you see, the energy, the particle is vibrating back and forth this way, and as a result, energy is getting transferred from one particle to the another particle, and as a result, the wave is formed because of the compressions and rarefaction. Compressions where the particles are in just together with each other, and in rarefaction the particles are away from each other. So when we talk about the waves, basically in 11th class we have to talk about the mechanical waves. Mechanical waves means in which we need a material medium, while in 12th class you will be talking about the electromagnetic waves, which are formed because of the varying electric and magnetic field. So electromagnetic waves, they are always transverse in nature, while the mechanical waves, they can be transverse or they can be longitudinal. Like if I'm talking about the water waves, when I'm throwing a stone into the water, then the particles, they are vibrating up and down. So vibration is simply an oscillation with a small amplitude. So they are vibrating about their mean position up and down. So when they are moving up and down, then crest and troughs are formed. And in this case, when we talk, when I'm speaking and you are getting my sound, then in the air, the particles are moving back and forth. And as a result, the waves which are formed, they are longitudinal waves because of the formation of compression and rarefaction. So in the longitudinal waves, density is getting changed, while here the displacement is getting changed. Of course, if I take this as the direction of propagation, it means the wave is moving, propagating, it means it is progressing. So here the particles are moving in the same direction of the wave of propagation, means they are vibrating back and forth, while their movement up and down without leaving their actual position. So they are simply vibrating and they are not leaving their actual position. That point is to be noted. And only the energy is getting transferred while the vibration of the particle. So this particle is remaining here only, but it is vibrating up and down, or it can vibrate back and forth. So if it is moving back and forth, then longitudinal waves are formed. And if it is moving up and down, then transverse waves are formed. And in transverse wave, we talk about crest and trough. Crest is the particles which are above this line of reference, and trough is this part which is below the line of reference. Because transverse waves, they can be formed on the surfaces of the liquid, not inside. It is formed only on the surface of the liquid. And if I am just throwing a stone with the small force, then a pulse is created. Pulse is a wave of short duration. So all these things you have to keep it in your mind. While in longitudinal waves, I can say compression and rarefactions are formed. Compressions are the area of the higher density, while rarefactions, the particles are very away from each other. So you can say that is rarefaction, where the low density is there. So in the rarefaction, low density of the particles is there, while in compression, it is an area of high density. So this way, you should be able to just differentiate between the transverse and the longitudinal waves, which are mechanical waves, because our main concern here in class 11th is on mechanical waves. So whenever I am talking about waves, I mean mechanical wave. While these electromagnetic waves, I will be talking in class 12th with you, when we talk about the electromagnetic waves, which are always transverse in nature. They do not need any material medium like light waves, radio waves, X-rays, but of course they can travel through the medium also. So these are transverse, means up and down movement is there. But if graphically you see for the wave, this is a sinusoidal graph is there. So it means it is an harmonic. So it means the particles, they are, while moving up and down, they are having SHM, simple harmonic motion. And the motion of the particle can be represented as a sinusoidal graph. So whatever we have studied the characteristics of the SHM, they all will be applicable here. And if I want to talk about the characteristics of this waves, it means what it is, the particles are having SHM. It means I can even consider the spring type model with me to understand the waves. Like the particles, they are behaving like the springs. So when they are behaving like springs, so when it is getting stretched on, means extended on one side, so restoring force is produced. So that restoring force is trying to bring it back to its initial position. So for bringing it back, I should be having the inertia should be there, the elasticity should be there, and this medium, then only the particles can be having the wave motion, which is actually each particle is having SHM. So the concept of simple harmonic motion should be clear before we go ahead. So that is why I said that when we are talking about waves, you should be very clear about the oscillations with you, SHM, periodic motion, every concept should be clear with you. And of course, here when we are talking about, then this is the wave, complete wave. Wave is traveling with a particular velocity in a given direction, that is wave velocity. But the particles, they are vibrating up and down, that is particle velocity. So these two things also we will be discussing in detail in the coming lecture. So particle velocity is different, while wave velocity is a different thing. So these two things we have to study, and of course each particle is having the SHM. That concept should be in your mind. It means we should be talking about the restoring force, which is bringing the particle back to its mean position. So all these things should be clear with all of you. So when I talk about the essential properties of the medium, it means what the characteristics of the medium should be there for the propagation of mechanical waves. So it means I want to bring the particle to back to its mean position, either if it is having back and forth motion or it is having up and down motion. So the characteristics which it should have, that is first characteristic is elasticity. Because if the particle is, this medium is not elastic, then the particle will not be able to return to its mean position. So this is the first important property of the medium, that it should be having some elasticity so that the particle can return to their mean position. And second is, of course, it should have the inertia, so that the particle, as we have said in the SHM, when the bob motion or the spring motion is there, then what is happening? The particle is coming back to its mean position when you are stretching it. And when you are bringing it here at this position, it is having the potential energy maximum, and here it is having kinetic energy maximum. Here it is having, again on the another extreme, it will be having the potential energy. So it is able to store the kinetic energy, because potential energy is getting converted into kinetic energy and so on. So when the particle is moving, then the particle is able to store the kinetic energy. So it means the medium should be having some inertia so that it is able to store the energy. And of course, it should be having minimum friction, because if the friction is more, then the particle will stop immediately. And if we want the wave, which is of course sinusoidal, I have said. So this is the wave diagram. If you see sinusoidal diagram, I can have the displacement or density depending upon whether I am having the longitudinal or the transverse wave. In the transverse wave, displacement is changing with the distance, while in longitudinal wave, density is changing because compression and rarefactions are formed with the distance, means with the propagation of the wave. So it should have minimum friction so that it can continue oscillating for a sufficiently long time. Otherwise, the wave will vanish immediately as soon as you store stone. So it will be just a pulse, not a complete wave will be there. Pulse means I'm talking about a wave of short duration. This is like that started, but immediately it ended. So we are not able to have even a complete wave. This, as I have discussed with you, that when I'm talking about the transverse wave, means up and down motion, I can have in the strings, or I can have on the surface of the liquids. In the strings, as we have discussed in the sonometer experiment also, so that also we will be repeating in detail. So transverse wave, up and down, we can make the wire to vibrate. So strings, in the strings I can have, or on the surface of the liquids. While longitudinal waves, they can transmit through all the three medias. It means solids, liquids and gases. That is your common observation when I am speaking with you, even if as if I'm getting the sound from behind on the road because the vehicles are moving. So that sound I'm able to get because the sound is getting transmitted from the various mediums in between. Like the doors are there, walls are there, so they are able to travel through solids, liquid as well as gases. So this thing is to be noted, and of course you should be able to differentiate between the longitudinal and the transverse wave. As I've said, in the longitudinal we are having crest and trough. When I'm plotting the graph between the displacement and distance, this is your transverse wave because the particles are moving up and down, vibrating up and down, not moving. They are staying on its position, but they are simply vibrating up and down. While in longitudinal wave, particles, they are vibrating back and forth. So the particles, they are vibrating back and forth in the longitudinal waves. So when they are vibrating back and forth, then the density is getting changed. With the distance, density is getting changed. So this is longitudinal wave. Fine. And when the displacement, because up and down movement is there, then it is your transverse wave. So see, both the waves, they are having the sinusoidal graph with you, but the parameters which you have to take along the y-axis are different. On x-axis I have taken distance, or I can even take time. So with the time also it will be having the sinusoidal graph, and with the distance also it will be having the sinusoidal graph. So these things, of course, you should be able to differentiate. Examples already I have discussed. For the transverse wave, you can say water waves, or the when you make the string to vibrate in the musical instruments, that is also transverse wave. While longitudinal waves, they are the sound waves with you when density is getting changed with distance. So few definitions also we have to see. These definitions even we have discussed in the oscillation chapter, but now with reference to the wave when I am talking, then also I should be able to define these things. Like here for mechanical waves, here I can have the displacement or I can have the density depending upon longitudinal or the transverse wave. And here I am having the distance in the direction of propagation. So amplitude is the maximum displacement. If I'm talking about, this is the amplitude. At the different positions, I can see the displacement. So maximum displacement, that is termed as the amplitude, and time period, that is the time taken to complete one wave. So this is one wave, that is time which is taken, that is termed as the time period. And of course denoted by capital T. Amplitude you can denote by capital A. Of course amplitude is the distance, so the unit will be meter or centimeter. For time period you will be measuring it in seconds. Frequencies, number of waves in unit time. It means that is your reciprocal of the time period, which is measured in per second, you can say, or you can measure it in hertz. Angular frequency, that is omega, that is 2 pi by t or 2 pi nu, of course, radian per second, you will be measuring it. Lambda, that is the wavelength, that is the distance which is traveled by one wave, that is your lambda. Or another way you can say the distance between two consecutive crest or two consecutive trough. It means the points which are in the same phase of vibration. Distance between two consecutive points which are in the same phase of vibration. This is another definition from your point of view. This particle A and this particle B, they are in the same phase of vibration. So distance between two consecutive particles which are in the same phase. This is also going to move up. This is also going to move up. Or I can take these 2 points C and D, distance between two consecutive crests. The common definition is the distance between 2 points, consecutive points, which are in the same phase of vibration, that is termed as wavelength, and of course it is denoted by lambda, and being the distance, it is again measured in meter or in centimeter. SI unit will be meter or centimeter. Number, that is the number of waves present in the unit distance of the medium. It means 1 meter distance if I take, then what is the number of waves present in 1 meter distance, that will be termed as wave number. Can be denoted by nu bar, just a line over the nu bar I call it, or I can say 1 upon lambda. So reciprocal of the wavelength, that is wave number. And so unit will be meter inverse. This concept with a wave number, angular wave number are important of course. Angular wave number, which I call it as the propagation constant also for the wave, that is simply the 2 pi by lambda. Like we have discussed in SHM when I talk about, then when the particle is completing one circular path, then the projection on the x-axis or the y-axis, they are having the one complete cycle of oscillation. It means here when particle is, projection is coming here. So when the particle is here, it is coming here. So in the meantime, this is completing one complete circle. The particle is, projection is moving from mean to extreme, back to mean, to the another extreme, then back to mean. So it is completing one complete vibration or oscillation. So the time, it means time period is capital T, distance traveled is lambda. And what is the phase difference? That is 2 pi. So this is, I can say it is simply representing the phase change with the path difference. Path difference, distance traveled, that is lambda, and the phase which is there, that is 2 pi. So the units are radian per meter. This propagation constant K, we also will be talking number of times, even we have discussed in the previous lesson also. Now, if I talk about the wave velocity, or which I can call it as the phase velocity also, that is simply the distance covered by a wave in a unit time in its direction of propagation. It means in which direction the particle is moving. That is your wave velocity or phase velocity. So this, of course, there is an apparatus on wave machine. Wave machine is there. From there, if you see, I will show you also, and that is showing you all these concepts in a very comfortable manner. So I may share the link with you so that you can observe. What is the relation between the wave velocity, frequency, and wavelength of wave? That is important with you. So when I talk about the wave velocity, that is distance traveled by the time taken. So when the particle is traveling this distance lambda, then the time taken is capital T, time period of the wave. So I can say V, it is equals to lambda by T. And 1 upon T, I can write it as the nu, which is the frequency. So I can say this wave velocity, that is given by nu into lambda. So this relation we will be using. So the concept of wave velocity should be clear. Wave velocity is simply the velocity of the wave, I can say. So parameters here, of course, you can write, that is displacement, or here it is distance. So or I can have the density if I am talking about the longitudinal wave. So whether I take longitudinal wave or I take the transverse wave, this graph will remain the same sinusoidal graph showing the SHM, simple harmonic motion of the particles. So of course about the particle velocity we will discuss in the coming lecture. Small question with you so that you are able to relate the concepts which we have learned. The question is that if a splash is heard 4.23 seconds after a stone is dropped into a well, which is 7.84 meter deep. You have to find speed of sound in air. So you have to write the things which are given to you in the question. Like distance I have taken 78.4 meter. Acceleration is acceleration due to gravity 9.8 meter per second square. Initial velocity is 0. So you can find the time which the stone will take to reach this well. So that you can find simply by using the second equation of motion, and on solving I am getting time equals to 4 seconds. And if I take, suppose that t dash is the time of splash of sound to reach the top of the well, then it means time which is taken by this sound to reach to you, that is coming out to be, by simply putting the values of the time which I have calculated to reach the stone in the water. As soon as the stone is touching the water surface, you are going to get the splash sound in a fraction of seconds. So sound will be traveling in the air above the water. As you are throwing the stone is reaching on the surface of water and you get the sound of splash. So this distance through which the stone is falling is 78.4 meter. So t plus t dash, I am getting 4 plus t dash. So on solving, I am getting t dash, which I am assuming the time of splash of sound to reach the top of well, and that I am getting 0.23 second. So speed of sound when I have to calculate in air, that is simply distance upon time, and distance the sound is traveling is 78.4 meter, and time I have calculated, it is 0.23 seconds. So you have to solve it to get the speed of sound in air, which is coming out to be 340 meter per second approximately, I can say. And you can leave up to 340 meter per second, or if you can solve, you are getting the result 340.87 meter per second. So bache, you are supposed to keep things up to this for today. Thank you everyone.